Okay, today on the Wilkin Way we have 3.3 properties of logarithms. So I've already written down the example, so you might have to pause the video to get those down, but let's just go through it. So we're going to start with the first 3 out of 4 properties, and the first one is the product rule. And the product rule says that if you have a logarithm and you're multiplying two things within the argument, if you want to write it another way, you're actually going to split that up into 2 separate logarithms with the same base and then add in between them. So just because we've talked about how exponentials and logarithms are inverses of each other, an exponential equivalent rule is like this: if you're multiplying between the bases, then you add the exponents. So this is the inverse of that rule right there. The next rule that we're going to be going over is the quotient rule, which says that if you are dividing within the argument of a logarithm, you can take those values and put a minus sign between them. So the exponential equivalent of that would be if I was dividing something like that, then we subtract their exponents. And again, the reason why I'm showing you this is so that if you forget what to do, but you know that exponents are the inverse of a logarithm, you can fall back on prior knowledge. This one's a little bit different. This one's saying if you have the argument with a power in it, you can take the power and multiply it to the front of the logarithm. So the exponential equivalent of that is something like this, where if you have a power raised to a power, then you multiply those exponents. Okay? So what we're going to do first is we're going to expand these logarithms, and basically what you're going to do is like go, how many values do I have here? And in this case, 1, 2, 3. So when you expand it, you should have 3 logarithms, and they should always have the base of the original logarithm. So here's log base 4 of 3xy, and what's happening between 3 and x and y is that we're multiplying, so we are going to add them when we split them up. Okay, so that's what that one looks like. When you're doing these, you're always going to want to make sure that you check to see if you can simplify any logarithms. And so what I mean by that is 4 to what power is 3. That's not something that you can do really easily. You would have to use a calculator. 4 to what power x and 4 to what power y, those can't be simplified because they have variables, so we're going to leave it just like that. Okay, so then we're going to go to the next one. And one trick that I'm going to tell you about that will always work, and it's if it's in the denominator, it will always be subtraction. So I'm going to show you the quick way to do this, and then I'll break it down for people who might try a different way. So let me just start with the quick way. So these two I know are going to be in the numerator, and they're being multiplied, so I'm going to have an addition sign before them, and then I have to worry about that power. And then these two are in the denominator, so they're going to be subtraction. So what I would do is just go like this: log base 7 of 5 plus, so that's the first value. Now I'm going to work on this next value, and I'm putting that power out in front because when you expand, the power goes out in front. Now I'm working on this one. The 3 only belongs to C, so I'm not going to write a 3 in front of B. And then again, I'm subtracting again. And I know some students are going to say, but you're multiplying in the denominator, so shouldn't you be adding? I'm going to show you why it ends up being subtraction if it's in the denominator no matter what. I just wanted to show you the shortcut of that, and you're free to use it if you use it properly. So that's our answer, and I'm just going to do a quick scan to make sure that I can't simplify any of these logarithms. But what happens is sometimes students need to see this little piece right here where they will go and say, oh, okay, so what if I did it like this? What if I said, not really working there. All right, maybe this one. Same color? I don't know. Okay, if I said What if I split it up like this? Log base 7 of 5a squared minus log base 7 of bc cubed. So you see that right there, that's taking care of the division right there. And then I'm going to split this up, and that's going to be log base 7 of 5 plus 2 log base 7 of a. But then you have to remember that when you do this minus right here, what you're actually doing is subtracting. And you can see the multiplying changing into addition right here. But remember that minus sign means we have to subtract everything to the right. So it means I would distribute that minus, and if I distribute that minus, then I have what's right there. So it's just easier for me to remember that if it's in the denominator, to make sure I put a subtraction in front of it. But there's definitely a step-by-step way that shows that you get the same answer. Okay, so what happens when we have a radical like we do in example 3? Well, first thing you're going to do is split it up to be a logarithm, and in this case a natural logarithm with the radical by itself. And then what we're going to do is rewrite, which this is a little, not a little part of math, a big part of math is just rewriting it to be able to use it how you need to use it. So instead of writing the square root of xy, I'm going to write this as xy to the 1/2. So I'm switching that from radical notation to exponential notation, which then allows me to do ln of 3 plus, and that 1/2 goes to both of those because there's parentheses, so 1/2 natural log x plus 1/2 natural log y. And again, a quick scan to make sure I can't simplify any of those without a calculator. The last one, D, looks intense, but we can handle it. So first thing we can see, that's really just x to the 1/3 if we rewrite it. And then we have a 25y squared in the denominator, so we know those are going to be minuses. So we have 1/3 log base 5 of x from the numerator minus log base 5 of 25 minus 2 log base 5 of 20 of y. So you might think like, okay, you're good, but you just have to be careful because you're not as comfortable with logarithms that you need to look for things like this right here. So 5 to what power is 25, and that is 2. So we do have to write that as minus 2 log base 5 of y. Now if you want to put this minus 2 at the end, that's fine too, it doesn't matter, but I'm just going to leave it like that for now. Alrighty, moving on to condensing. So here we were given a single logarithm and we expanded. Now we're going to be giving the expansion side and asked to condense. When you condense, you write it as a single logarithm, and we'll use this in the 3.4 lesson as well. So what you're going to want to do is just work backwards. So this 2 is going to come up here. Same thing, this 1/3 is going to come up here. I encourage students to cross out the second ln, or if there's 3 of them, the second and third, so you don't write that in there. And then remember that this right here actually means we're going to multiply. So it looks like this: the natural log of x squared times x plus 5 to the 1/3. And if you want to be fancy, then you can write this as ln of x squared times the cube root of x plus 5. So I would take either of these answers right here. Okay? So then we're going to move on to this one. And just like before, when we said if it's in the denominator, you always subtract, we can rephrase that to say if it's subtraction, it's in the denominator. Okay, So I have two subtractions. So what you can also do is change those to divisions to help yourself remember. Again, these are just things. I don't want you writing those. These need to come up. So it's all how your brain works, because for some people that's really intense. But for me, it can handle that pattern. So it's up to you. So this is going to be log base b, and we have x to the 1/4, and then we have 5 squared, and we have y to the 10th, and then I'm just going to write that again a little bit neater and simplifying anything I can, and this would be the 4th root of x over 25 y to the 10th. Make that right there. And you do need to do the 5 squared. So if you didn't want to convert the x to the 1/4 to a radical notation, that's fine. Okay, so you're going to need your calculator for the next part. It's called the 4th property, is change of base property. And basically what the change of base property is going to allow us to do is to change from some base that's not in our calculator to a base that is in our calculator. And our calculator, we have two bases. We have log base 10, which is this one right here, and this is natural log. The button's been worn off, but you can tell the property of inverses, because if you see the second key, which is the blue one right here, it would say 10 to the x, which is the inverse of log base 10 of x, and this says e to the x, which is the inverse of ln of x. So the people who made the calculator were smart and knew what they were doing. So those are the two buttons that are in our calculator. There aren't buttons like log base 3 of 5 and things like that. So the change of base property basically says if you have a logarithm of some base and you want it to change it to base 10, then take the log of m, so log base 10 of m, and divide it by log base 10 of b. So m is your argument. The argument goes on the top and the base goes in the bottom. Or if your preference is natural logs, you can do the same thing with natural logarithms. You take the natural log of your argument and divide it by the natural log of your base. The way that I remember this is, first of all, b is at the bottom, so it should be at the bottom, and also it's kind of lower when you write the base of that logarithm. It's lower, so it belongs in the bottom as well. Okay? I'll leave that up there for a second so that you can pause it and copy it down. All right, so then we're moving on how to evaluate these right here. So example 3 says evaluate log base 3 of 5. So what I would do, it's really your preference. What you're going to do is change the base. So this is log base 3. So we learned that if we change it to log base 10, we put the argument, the log base 10 of the argument in the numerator, and the log base 10 of the base in the denominator. And then we're going to round to 3 decimal places. So here's the calculator. Log, so this is log base 10 of 5. Close out your parentheses and divide it by log base 10 of 3. And we get approximately 1.465. Okay? Now maybe you're like, I don't really like log base 10. My favorite is natural log, because natural log is only 2 letters, so it's less I have to write. So it's the same thing, the natural log of the argument divided by the natural log of the base. Natural log of 5, close out that argument, divided by the natural log of 3, close out that argument, and we get the exact same thing, as we should. You do not have to do both. You just get to pick one or the other unless it's specifically needed, and I'll show you an application of the change in base that shows up on your test in a minute. Okay, so this is just another one for you to practice. So I'm just going to use the natural log since it is less to write. So this is the natural log of 17 over the natural log of 6, which is, when I plug into my calculator, boop, 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 you should be getting 1.581. So example 4 and example 5 are just problems that are using our properties. It makes sense because today we're doing properties of logarithms, so how do we apply these? So here's one application. This one is going to be one of the first three properties, and this one is the change of base property. So the way I'm going to know which property I'm supposed to use is based upon what I'm given and what I'm asking for. So if you look right here, log base b of 2 and log base b of 3, do any of these have a different base than that right there? No. So I wouldn't use a change of base formula because it wouldn't make sense because I don't need to change the base. So this is A, and this quantity here is C, and we want to write these expressions in terms of A and C, and these are specifically chosen. So I'll show you how to do the first one just to give you an idea. So again, we are going to rewrite 6 as log base B of 2 times 3. The reason why I'm looking at that is because I'm going to look ahead and see if I do 2 times 3, or if I can somehow get log base b of 2 and log base b of 3, then I can change it and write it in terms of A and C. Well, now that I've chosen to write it like that, then I can expand it using the properties of logarithms, and I get that right there. So log base b of 2, another name for it is A, and another name for log base 3 of C, or of 3 is C. So in terms of A and C, I would just write A plus C. Now you don't have to use both of these, so don't think that you do. You just have to be able to manipulate what you're given. So when I see log base B of 81, I think of 3 to the 4th power. And then what I'm going to do is, again, I'm trying to isolate log base b of 3, so I'm going to move this down into the front. So that equals 4 log base b of 3. And I can write log base b of 3 as c. So that's just 4c, and that's good. This one's probably a little trickier, but we've seen radicals already. So we have log base b of 3/16 to the 1/2. Okay, shower that power. So we have 3 to the 1/2 over 16 to the 1/2, which we get log base b of 3 to the 1/2 minus 16 to the 1/2 is 4. So log base b of 4. I'm starting to see that log base b of 3, so I'm going to move this into the front, and that gives me 1/2 log base b of 3 minus, and I want to write 4 in terms of 2, so I'm going to put log base b of 2 squared. That 2 is going to come down, so I have, let's get this out of the way, 1/2 log base b of 3 minus 2 log base b of 2. So that's going to be 1/2 c minus 2a. Okay, so you're just manipulating to be able to, you're manipulating the arguments to be able to rewrite these in terms of A and C. Okay, last example. Also a tricky. These ones show up on your test, so you're going to want to make sure that they become flashcards so that you know how to do these. This says if log base 10 of 4 is A and log base 10 of 3 is B, find log base 3 of 1/16. So notice how A and B are base 10, and notice how the given one is in base 3, so we have to use a change of base formula, and we definitely don't want to use the natural log for this one because the given ones are base 10. So what we're going to do is we are going to start by using the change of base formula. So log, and this is going to be 1/16, log base 10 of 1/16 because that's the argument, over log base 10 of 3, and you can see we already have B, right? So we just need to manipulate this to be able to write it as log base 4. So we go log base 10 of 1/4 squared all over log of 3, which is log base 10 of 4 to the -2 all over log of 3, which is -2 log 4 all over log 3, which now allows us to rewrite it as negative 2a divided by b. And that's all we have for today. Have a good one.